Today we will build a novel electric gripper. Dimension-wise, this would be ideal. Short in the axial direction, compact, lightweight, and also quite powerful. Problem with this one, it's pneumatic, which means the force transmission is binary, so basically open and close. And also you need to carry a big and loud compressor with you. We want to exchange our end effectors, our grippers, and need one integrated system. If you look at industrial solutions, first of all, they are very expensive. Most of the time they have this big axial stack, which means they are very far away from the actual wrist joint. And so we came up with the following solution. We will sense the torque with a very big direct drive style motor, which means we don't need a gearbox. We will just use a spiral to transmit the rotary movement to the linear movement. And now we will start to actually manufacture it. To control our gripper, we are using a standard BLDC controller. This one is from Moteus. Big shout out to Josh. It just makes sense right here to use something standard because we don't want to use our internal bus of the robot arm. With this controller, we are able to get a holding torque of 0.5 Newton-meter, which transmits to about 6 kilograms of clamping force. Why do we even need force sensing? Well, the answer is short and easy. Contact manipulation. Tasks where you need to feel, and if you think about it, we humans highly benefit from feeling stuff that we manipulate, and also, very important, hearing. So I constantly find myself messing things up if I'm wearing headphones, because you really lose spatial awareness. So we highly concentrate on also working with forces or torques. One thing that's quite cool about this torque transparency is bilateral teaching. So we have no force sensor in here or anything, just the PID lobe of the controller. And we are able to feel with a controlling device, so basically a copy of this gripper, an obstacle in our robot gripper. And so by pressing harder on the controller unit, we can teach the robot how firmly it should grasp. We are very pleased with the performance of this gripper and the simplicity, which is also very important because in these robotic systems you have so many precision parts, and this one's quite easy to manufacture. It's self-aligning, you don't need to really calibrate anything, it's self-centering also, so quite an elegant solution. However, one disadvantage of course is the limited range by the spiral. So if you want to have a gripper that has, let's say, 150mm reach, you would need a big disc, a big spiral. That doesn't make sense. This is kind of the sweet spot where this works. No gear machining with quite low inertia. Anyways, hope to see you again and thanks for watching.